In this lesson, we will learn about permutations. So a permutation is an arrangement of objects that is ordered. So in this case, the order would matter. So obviously in spelling, the order does matter. In this question, it says, how many ways can the letters in the word cows be arranged? So I can have C-O-W-S, or I can have C-O-S-W. I could have C-W-O-S, or I could have C-W-S-O. I could have C-S-O-W, or C-S-W-O. Or I could then start with a different letter. So I could have O-W-S-C, O-W-C-S, etc. I'm going to continue this list off air so you don't have to watch me write them all down. Shoo, I'm exhausted. But as you can see, I have 24 different possibilities here. That's the way in which the letters in the word can be arranged. So 24 different ways. Now, it's kind of a pain in the rear to write all of these out, and as you can see, I messed up a couple of times and had to scribble them out, but you get the idea that this is sort of tedious and long and doesn't make much sense. So instead, we're going to look at the number of permutations as being n factorial. So in my last example, I had 4 different letters. And so that would be 4 choices for my first letter, 3 choices for my second letter, 2 choices for my third letter, and 1 choice for my last letter. Now we've talked about factorial, and factorial says start at whichever number I give you and multiply by every number down to 1, and that's exactly what I have here. So 4 times 3 times 2 times 1 gives me 24 total options. So instead of writing all of them out, I could have just reasoned through it like this: 4 times 3 times 2 times 1. Now, that's for just a normal permutation. Sometimes you're going to have a permutation of n elements, and some of them are going to be the same. So in the word cows, C, O, W, and S were all separate letters. But say I took the word room, well, those 2 letters are the same, and so I would count those sort of as 1. So if I was doing that, instead of 4 factorial, I would have 4 factorial on the top, and then on the bottom, if I have some that are indistinguishable, meaning those 2 are essentially the same thing, I would then say that's 2 factorial on the bottom, because I have R1 is the number of duplicates of one kind. So I have 2 duplicates. So I have 2 values that are the same, and so that's 2 factorial. So this is 4 factorial over 2 factorial, whoops, which is 12 different ways. I'm making a big mess of it. But 12 different ways, because that would be 24 divided by 2 times 1, which is 2. So 24 divided by 2, which is 12. So that's the number of permutations if some of them are indistinguishable. So let's look at a couple of practice. Determine the number of ways that 7 people can stand in line. Well, we're going to assume that all 7 people are different. So that's going to be 7 factorial. So use your calculator, and I get 5,040. Now determine the number of ways the letters in the words Mississippi can be arranged. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial, except we've got some letters that are duplicated. So M only happens once, but I've got 1, 2, 3, 4 I's, so I'm going to divide by 4 factorial. I've got 1, 2, 3, 4 S's, so 4 factorial again, and then I've got 2 P's, so 2 factorial. Again, we talked about a way to reduce this a little bit. This would be like 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. And so one of those 4 factorials would reduce. Then I still have 4 times 3 times 2 times 1, and then times 2 times 1. So again, anything else I can reduce, like 8 is the same as 4 times 2. 6 is the same as 3 times 2, and so now my denominator is essentially 1. And my numerator is 11 times 10 times 9 times 7 times 5, which is 34,650 different ways. So it would have been far more than that, 39 million something, if all of these were different letters, but because we had so many repeats, we divided by so many things, there are only 34,650 options. Here are 2 questions for you to try on your own. So press pause, try both questions, then press play to check your work. So here, determine the number of ways that 4 books can be arranged on a bookshelf. So obviously we're talking about order mattering because we have how can they be arranged. Well, we are to assume that they are all independent, different books. So of course that just means 4 factorial. So 4 times 3 times 2 times 1, which of course is 24. The number of ways the words in, or the letters in Bellevue can be rearranged. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 factorial. And then we look at duplicates. So I have just one B. I have 1, 2, 3 E's. So that's 3 factorial. And I've got 2 L's. So that's 2 factorial. And the rest of them are all separate letters. So that gives me 8 times 7 times 6 times 5 times 4 times 3 factorial, and then 3 factorial times 2. Those 3 factorials reduce. I'm going to go ahead and reduce this 2 and this 4 also, and that leaves me with a denominator of 1, and I'm going to multiply 8, 7, 6, 5, and 2 to find my solution, which is 3,360. That's how many different ways we can rearrange the letters in Bellevue. This brings us to the formula for the number of permutations of n items taken r at a time. What that means is that we are worried about the order of something, and again, that's because it is a permutation, and permutation means that we care about the order. And this assumes that, say for instance, x, y, and z, we have 3 different letters, and we're taking them 2 at a time. So in essence, we're saying, okay, we have xy, we have xz, we have yx, we have yz, we have zx, and we have zy. So there should be 6 different ways, and again, the order does matter. So xy and yx are 2 separate items. So the number of ways I can do that is 6. I can use this formula to do that. So N, P, and R, the N stands for the number of items, and then R at a time. So this would be 3 items taken 2 at a time, which means 3 factorial. And on the bottom I have N minus R, so 3 minus 2 factorial, which is 1 factorial. 1 factorial, which is 3 times 2 times 1, or 6. 6 different ways. So n factorial divided by n minus r factorial. So do both of these questions and then press play to check your work. So for the first, I have 7 items, 3 at a time. And again, that tells me that it is 7 factorial over 7 minus 3 factorial. So I'm subtracting the 2. So 7 factorial over 4 factorial, which would be 7 times 6 times 5 times 4 factorial. And all of that stuff cancels to just give me 7 times 6 times 5, which is 455. Now, interpret its meaning. That means that there are 455 different ways in which I can choose 3 items out of 7 if the order that I choose them makes a difference. In how many ways can 12 runners come in first, second, and third? So obviously if we're giving medals, we do care about the order because I would rather have first than third place. So this would be 12P3, meaning I have 12 items, I'm taking them 3 at a time. How many ways can that happen? It would be 12 factorial over 12 minus 3 factorial. So that would be 12 times 11 times 10 times 9 factorial over 9 factorial. And those would cancel. And that would give me 1,320. Now again, we're using this permutation formula, but we can also reason through this. If I have 12 runners, I have 12 different ways, 12 different runners that can come in first. I then only have 11 different people who can come in second because this person already has first and you can't get both. And then these two places have already been taken. There's only 10 runners left who could get third, and we don't care about the rest of them. And the 12 times 11 times 10 is the same answer that we got. So this formula just helps us to find that solution without having to write them all out.